Students, hopefully you are doing well in your studies, and today we are going to discuss few questions case study based from ray optics. So students, as you must be knowing कि इस साल हमारे एक सेक्शन सी के अंदर केस स्टडी का एक क्वेश्चन आने वाला है 5 मार्क्स. So students, so let's start with case study. When case study does not mean unseen passage कि आपको सारे आंसर्स उसी पैराग्राफ में मिलेंगे. केस स्टडी मींस टू गिव यू अ ग्लिम्स कि इस टॉपिक के बारे में डिस्कशन होने वाली है. यू मे नॉट गेट द आंसर डायरेक्टली फ्रॉम द पैसेज. तो अगर आपके पास टाइम नहीं हो तो आप डायरेक्टली क्वेश्चंस पे भी आ सकते हैं. जैसे फॉर एग्जांपल इफ आई लुक एट द क्वेश्चन नंबर 1, a point object O is placed at a distance of 0.3 meter from a convex lens of focal length 0.2 meter, cut into two halves, each of which is displaced by 0.0005 meter as shown in the figure. What will be the location of the image? Now, friend, if I look at the case study, a convex or a converging lens is thicker at the center than at the edges. It converges a parallel beam of light on refraction through it. It has a real focus. Convex lens is of three types: double convex lens, plano-convex lens, concavo-convex lens. Concave lens is thinner at the center than at the edges. It diverges a parallel beam of light on diffraction through it. It has a virtual focus. फ्रेंड, इस क्वेश्चन का डायरेक्ट आंसर देखिए, इसको यहाँ पे आपको कहीं नहीं मिला. तो स्टूडेंट, कॉन्वेक्स लेंस के ऊपर आपने यहाँ से बीच में से कट कर दिया और यहाँ पे आपने ऑब्जेक्ट रखा. ना आपको कहा गया कि इमेज कहाँ मिली. नाउ लुक एट द सेकंड क्वेश्चन आल्सो. Two thin lenses are in contact and focal length of the combination 80 centimeter. If the focal length of one lens is 20 centimeter, the focal length of the other would be, again for numerical base. Look at the third one. A spherical air bubble is embedded in the piece of glass. For a ray of light passing through a bubble, it behaves like. Students, as I said कि आपको डायरेक्ट आंसर इस पैराग्राफ के थ्रू नहीं मिलेंगे. Question number 4. Lens used in magnifying glass is. Question 5. The magnification of the image by convex lens is positive only when the object is placed. Now students, आपको ये all 5 questions talk about convex lens, its nature and numerical base. So let's come to the answers. क्वेश्चन नंबर 1, उसने कहा था कि अगर बीच में से हम लेंस को कट कर दें. फ्रेंड, क्वेश्चन में u 30 सेंटीमीटर इट वाज मेंशन. बेटा देखिए, क्वेश्चन के अंदर u 30 सेंटीमीटर मेंशन था. फोकल लेंथ 20 सेंटीमीटर थी. फ्रेंड, इमेज बनने के लिए एटलीस्ट 2 रेज शुड बी देयर. और फ्रेंड, आप अगर लेंस को हॉरिजॉन्टली कट करते हैं तो फोकल लेंथ पे कोई डिफरेंस नहीं आता है. So 1 by v minus 1 by u equals to 1 by f by length equation. So we can calculate v as 60 centimeter. Friend, अगर आप इसे vertically काटते हैं ऐसे तो focal length डबल हो जाती है, लेकिन अगर आप horizontal कट कर रहे हैं there will be no change in the focal length. Question 2, जहाँ पे combination of lenses के बारे में बात कर रहा था. Combination of lenses, that is 1 by f equals to 1 by f1 plus 1 by f2. Now student, combined focal length was given to you. One of the focal length was also given to you. You need to calculate the second focal length. Now look at the question again. Question 2 says the two thin lenses are in contact. Focal length of the combination is 80. If focal length one of the lenses is 20, find the focal length of other lens. That is 1 by f1 plus 1 by f2 equals to 1 by f. Now come to the third one. Question 3 was, if a spherical air bubble is embedded in a piece of a glass, for a ray of light passing through the bubble, it behaves like. Now student, आपके पास बाहर कॉन्वेक्स लेंस का रिफ्रैक्टिव इंडेक्स है और अंदर एयर है। तो बाहर हायर ऑप्टिकल टेंसर मीडियम हो गया, अंदर एयर है बबल के अंदर, तो अंदर ऑप्टिकल रेयर की तरह बिहेव हुआ, so it will behave like a diverging lens. Now students, come to the fourth one. Lens used in magnifying glass would be, student, for magnification we use convex lens. Now come to the fifth one. Magnification of an image by convex lens is positive. Now student, you must be knowing all the cases. अगर ऑब्जेक्ट एट फोकस पे है तो इमेज बनती है एट इंफिनिटी। अगर ऑब्जेक्ट है बिटवीन एफ एंड 2f तो इमेज बनती है बियॉन्ड 2f। अगर ऑब्जेक्ट है एट 2f तो इमेज बनती है एट 2f। बिटवीन एफ एंड ऑप्टिकल सेंटर तो ऑब्जेक्ट तो इमेज ऑन द सेम साइड बनती है और हाईली मैग्नीफाइड बनती है। नाउ स्टूडेंट, ऑन द सेम साइड बनती है, so that means magnification is positive. So option D is correct. Now come to case study number 2. Now student, case study number 2. First, I'll read questions for you. उसके बाद हम केस स्टडी के पैराग्राफ को भी देखेंगे। स्टूडेंट्स, मैं आपको क्वेश्चन पहले रीड इसलिए करके दिखा रहा हूँ ताकि आपको ये पता चल जाए कि इसमें से डायरेक्ट आंसर्स इस पैराग्राफ में नहीं मिलेंगे। तो अगर आप अपने पेपर के अंदर टाइम बचाना चाहते हो और आपको डायरेक्ट एमसीक्यूज के आंसर पता है तो आप डायरेक्ट उसके आंसर्स कर सकते हैं। A convex and a concave lens separated by a distance d are then put in a contact. The focal length of the combination will be. Second, if two lenses of power 1.5 diopter and 1 diopter are placed in contact, then the effective power of will be. Third, if power of the lens is plus 5 diopter, what is the focal length of the lens? Fourth, two thin lenses of focal length plus 10 centimeter and minus 5 centimeter are in contact. The power of the combination will be. Fifth, a convex lens of focal length 25 centimeter is placed coaxially in contact with concave lens of focal length 20 centimeter. The system will be. Student, ये आपकी combination of lenses के ऊपर question है। Now come to the case study. Power of a lens is given by reciprocal of focal length of the lens, that is P equals to 1 by f, where f is in meter and P in diopter. For a convex lens, power is positive, and for a concave lens, power is negative. When a number of thin lenses, power P1, P2, P3, are held in contact with one another, the power of the combination will be given by algebraic sum of the power of the lenses, that is P equals to P1 plus P2 plus P3 and so on. Now student, come to first one. A convex and a concave lens. But a convex lens की focal length positive होती है, concave lens focal length negative होती है, are separated by distance d and are then put in contact. The focal length of the combination will be. Now students, आपके पास the combination of lenses का क्वेश्चन है। तो अगर एक 1 by f equals to 1 by f1 plus 1 by f2 आप करके देख सकते हैं, और अगर आपको कोई कंफ्यूजन हो तो अपने माइंड में कोई भी एक एग्जांपल लेके कर सकते हैं। नाउ फोकल लेंथ कॉन्वेक्स लेंस के लिए कुछ भी एक एग्जांपल लेके चल सकते हैं। लेट अस 20, कॉनकेव के लिए लेट अस से 30, और आप कैलकुलेट करके अपने माइंड में देख सकते हैं। नाउ कम टू सेकंड similar one. If two lenses 1.5 diopter and 1 diopter are placed in contact, then the effective power would be P1 plus P2, that is 2.5 diopter. Now come to third one. If the power of the lens is plus 5, that means it is a convex lens. What is the focal length of the lens? That is 1 by f in meter. So you can calculate f as 1 by p, which is 1 by 5, that is 20 centimeter or 1 by 5 meter. Now come to the fourth one. Two thin lenses of focal length 10 and minus 5 with a plus 10, that is convex lens, minus 5, that is concave lens. are in contact, the power of the combination would be apply 1 by f equals to 1 by f1 plus 1 by f2. 1 by f is referred as power. So you can calculate these has to be in meter. So you can calculate the power of the combination, that is minus 10 diopter. Now come to fifth one. Fifth says a convex lens of focal length 25 centimeters is coaxially in contact with concave lens. Again, 1 by f equals to 1 by f1 plus 1 by f2 apply current. So you will get combined power or combined focal. If focal length is coming out to be negative or power is coming out to be negative, the system is diverging. If it would be positive, the system will be converging. Now come to case study number 3. Case study number 3 says total internal reflection is a phenomena of reflection of light into denser medium at the interface of denser medium with a rarer medium. For this phenomena to occur, necessary condition is that light must travel from denser to rarer and angle of incidence in denser must be greater than critical angle for the pair of media in contact. Critical angle depends on nature of medium and wavelength of light. We can show that mu equals to 1 by sin I c. Now come to question number 1. Critical angle for a glass air interface where mu of the glass is 3 by 2. Now student, critical angle which is 1 by sin I c. Mu is given to you. You can calculate sin I c. Students, आपको पता होना चाहिए अगर मैं इसका 1 by sin I c करूँ that is 2 by 3. बच्चों 2 by 3 that is 0.66. Sin 45 की वैल्यू होती है 1 by root 2 that is 0.707. Sin 30 that is half which is 0.5. So its value will be in between 30 and 45. Student, you must be knowing also sin 37 which is 3 by 5 0.6. तो 37 से बड़ा है. आपको 37 and 53 की वैल्यू पता होनी चाहिए. sin 37 होता है 3 by 5 and sin 53 होता है 4 by 5. So we can go with the options. It is 41. Now come to second. Critical angle for water air interface is 48.6 degree. What is the refractive index of water? Student, although we know that refractive index of water is 4 by 3 or 1.33. तो अगर मोस्ट ऑफ द केस में अगर आपको कुछ इम्प्योरिटीज नहीं डाली जाए तो आप इसका डायरेक्ट आंसर भी लिख सकते थे 4 by 3 और वी कैन कैलकुलेट 1 by sin I c. 45 की वैल्यू तो हमें पता होती है बट वी डू नॉट नो 48.6. तो हम ऑप्शंस के थ्रू अगेन देख सकते हैं कि इट इज कमिंग आउट टू बी 4 by 3. Now come to question number 3. Critical angle for air-water interface for violet color is 49 degrees. Its value for the red would be, now student, mu equals to 1 by I sin I c, that is critical angle. So critical angle is 1 by mu. We know that refractive index of mu is more than refractive index of red, and mu is inversely proportional to critical angle. So that means critical angle for violet is less than critical angle for red. So again, according to the option, it's C, because only option which is less than 49 is given 48 here. Now come to fourth one. Which of the following is not due to total internal reflection? Working of optical fiber, we know that it is an application of TIR. Difference between apparent and real depth of the pond, mirage, brilliance of diamond. Mirage and brilliance of diamond are also applications of TIR. Difference in apparent and real depth is an example of refraction. So difference in apparent and real depth is due to refraction. Other three are due to total internal reflection. Now come to the fifth one. Critical angle of a glass is theta 1 and that of water is theta 2. The critical angle of water and glass surface would be given glass refractive index is 3 by 2 and water refractive index is 4 by 3. Now students, glass का refractive index with respect to water, we know हम यहाँ से values देख पा रहे हैं कि glass का refractive index with respect to air is highest, with respect to water with respect to air, and then glass with respect to water. And sin IC is the reciprocal of mu. So theta order will be theta more than theta 2 more than theta 1. Fine. Now come to next case study. Friend, next case study. The lens maker formula is a relation between that connects focal length of the lens to the radii of curvature of the two surfaces of the lens and refractive index of the material of the lens. It is 1 by f equals to mu minus 1, 1 by r1 minus 1 by r2, where mu is the refractive index of the lens material with respect to the medium in which lens is held. As mu of violet is more than mu of red, therefore focal length of red is more than focal length of violet. Mean focal length of the lens for yellow color is root of focal length of red and violet. Now come to the question. Question 1 says focal length of equiconvex lens. The equiconvex lens मतलब दोनों तरफ का radius same है. Equiconvex lens of glass refractive index 3 by 2. Here is 20 centimeters. The radius of the curvature of each surface will be. Now student, अगर लेंस का एक तरफ से इंसिडेंट रे आ रही है तो R1 is taken positive, then R2 is taken negative. Mu is given to you 3 by 2. So we can calculate, and focal length is also given 20 centimeters. So we can calculate R here using lens maker equation. 1 by f equals to mu minus 1, 1 by r1 minus 1 by r2. R1 is taken positive and R2 is taken negative here. Using given values, we can calculate R. Now, come to the second. A substance is behaving as a convex lens in air and concave in water. Then its refractive index will be. Friends, we must know that lens reverses its behavior if it is put in a medium whose refractive index is more than the refractive index of the lens itself. तो आपको उसमें कहा है कि सब्सटेंस बिहेव कर रहा है कॉन्वेक्स लेंस जब वो एयर में है और वो कॉन्केव की तरह बिहेव कर रहा है जब वो वाटर में है. तो स्टूडेंट जो लेंस का रिफ्लेक्टिव इंडेक्स है वो इन बिटवीन एयर एंड वाटर होना चाहिए. When a lens is immersed in a medium whose refractive index is greater than that of the lens, its nature changes. Here the lens changes its nature when immersed in water. It means refractive index of lens is less than water but more than air. Now come to the next one, question number 3. Question 3 says, for a thin lens with radii of curvature R1 and R2, refractive index N and focal length f, the factor 1 by R1 minus 1 by R2 is equal to. Now again use lens maker equation, which is 1 by f equals to mu minus 1, 1 by R1 minus 1 by R2. So keep 1 by R1 minus 1 by R2 here and put n minus 1 in the denominator, so you will get the expression of 1 by R1 minus 1 by R2. Now come to fourth. A given convex lens of glass mu 3 by 2 can behave as a concave when it is held in a medium of mu equals to. But a convex lens, इसका refractive index 3 by 2 है. You want it should behave like a concave lens. तो आपको एक ऐसे मीडियम में डालना होगा जिसका रिफ्लेक्टिव इंडेक्स इस लेंस के रिफ्लेक्टिव इंडेक्स से ज्यादा है. Now चेक करिए कौन सा ऑप्शन ऐसा है जहाँ पे रिफ्रैक्टिव इंडेक्स 1.5 से ज्यादा दिखाई दे रहा है? तो स्टूडेंट, फोर्थ, 1/f = 1 mu - 1, 1/r1 - 1/r2। तो आपको यहाँ से 7/4 1.5 से ज्यादा दिखाई दे रहा है। नाउ कम टू नेक्स्ट वन, क्वेश्चन नंबर 5। The radius curvature of the lens of a double convex lens are 20 centimeter and 40 centimeter. मतलब R1 and R2 are given to you, and the focal length is 20. That is, f is given to you. What is the refractive index? Again, use Lensmaker equation. 1/f = mu minus 1, 1/r1 minus 1/r2. Use given values and calculate for mu. It is coming out to be 5/3 here. Now come to the next case study. Case study number 5. Astronomical telescope. An astronomical telescope is an optical instrument which is used for observing distant images of heavenly bodies like stars, planets, etc. It consists of two lenses. In normal adjustment of the telescope, the final image at is formed at infinity. Magnifying power of astronomical telescope in normal adjustment is defined as a ratio of angle subtended at the eye by the angle subtended at the eye by the final image to the angle subtended at the eye by the object directly. When the final image and the object both at infinity from the eye, it is given by f/f. To increase magnifying power of astronomical telescope, its normal adjustment focal length of objective lens should be large and focal length of eye lens should be small. Now student, आपके पास ये जो आपको केस स्टडी में भी आपने ये पढ़ा, ये आपके कंसेप्चुअल क्वेश्चन में भी पूछा जा सकता है कि किसकी फोकल लेंथ ज़्यादा होती है, किसका अपर्चर ज़्यादा होता है। नाउ कम टू क्वेश्चन नंबर 1। An astronomical telescope of magnifying power 7 consists of two thin lenses 40 centimeters apart in normal adjustment. That is finally given at infinity. The focal length of the lens would be, now आपको given है final magnification, that is FO/FE is 7. So we can say FO is 7 times of FE. Student, आपको distance between two lenses given है, that means length of telescope FO plus FE, which is given 40. Now use FO, that is 7 times of FE here. So you can calculate FE 40/8, 5 centimeter. Use FE 5 centimeter either in the equation. We get FO as 35 centimeter. Now come to the second one. An astronomical telescope has a magnifying power 10 in normal adjustment, that is FO/FE. Distance between the objective and the eye lens is 22 centimeters. The focal length of the objective. Student, it is similar to question number 1. Now apply again. FO/FE magnification is given to you. So length of telescope is FO plus FE. FO 10 times of FE. Calculated, you will get FO. You could also get FE. Now come to question number 3. In astronomical telescope, compare two eyepiece. Objective length has negative focal length, zero focal length, small focal length and large focal length. फ्रेंड, इसका आंसर आपको डायरेक्टली आपको केस स्टडी में गिवन था। ध्यान से देखिए, ऑब्जेक्टिव लेंस हैज अ लार्जर फोकल लेंथ देन द आईपीस। नाउ कम टू द नेक्स्ट वन। टू सी स्टार यूज सिंपल माइक्रोस्कोप, कंपाउंड माइक्रोस्कोप, एंडोस्कोप, एस्ट्रोनॉमिकल टेलीस्कोप। स्टूडेंट, टेलीस्कोप व्हिच इज यूज्ड टू फाइंड डिस्टेंट ऑब्जेक्ट, उसको व्यू करने के लिए यूज होता है, so its answer is telescope. Now come to fifth one. For large magnifying power of astronomical telescope, नाउ स्टूडेंट, इसका आंसर भी आपके पास केस स्टडी में अवेलेबल था. फोकल लेंथ ऑफ ऑब्जेक्टिव is more than focal length of eyes. Now come to next case study. Refraction through spherical surfaces. Refraction of light is a change in the path of light as it passes obliquely from one transparent medium to another medium. According to the law of refraction, that is sin I by sin r, is refractive index 2 with respect to 1, where refractive index to 1 is called refractive index of second medium with respect to the first medium. From refraction at a convex spherical surface, we have u2 by v minus mu1 by u, mu2 minus mu1 by r. Similarly, from refraction at a concave surface, spherical surface, an object in the rarer medium is u2 by v minus mu1 by u, mu2 minus mu1 by r. An object lies in the denser medium. Again, u1 by v minus mu2 by u, u1 minus mu2 by r. फ्रेंड ये जो आपके रिजल्ट्स हैं, ये रिजल्ट्स आपको याद रखने होंगे बिकॉज कई बार ये न्यूमेरिकल भी पूछ लेते हैं, so you must know the results also. Now question number 1 says refraction refractive index of a medium depends on. Now student, refractive index of a medium depends on the nature and temperature. Now student, तो इसका आंसर आपके पास 4, नेचर ऑफ मीडियम, वेवलेंथ बिकॉज हम लोगों ने पढ़ा है म्यू इक्वल्स टू a plus b by lambda की पावर 2 c by lambda की पावर 4 and so on. टेम्परेचर बिकॉज इससे ऑप्टिकल डेंसिटीज वेरी कर सकते हैं. ऑल ऑफ दीज इज आंसर. सेकेंड, a ray of light of frequency 5 into 10 to the 14 hertz is passed through a liquid. The wavelength of light measured inside the liquid is 450 10 to the minus 9 meters. The refractive index of the liquid will be. Now, refractive index. आपके पास refractive index, that is speed of light in air with respect to speed of light in medium. Now, students, आपके पास क्वेश्चन में wavelength given है. We know that speed equals to distance upon time. When distance stands for lambda, distance upon time, that is 1 by time period, and 1 by time period is frequency. This is frequency. This is velocity. This is frequency. So speed upon frequency into wavelength. Now all terms are given to you in the question. You can calculate refractive index. Now come to the third one. A ray of light is incident at an angle of 60 degrees at one face of rectangular glass slab of refractive index 1.5. The angle of refraction will be. Now student, you can apply Snell's law directly, which is mu equals to sin I by sin r. So you can calculate sin r, sin I by mu, that is sin 60 by 1.5. So you can calculate sin r. तो क्वेश्चन में आपसे r ही तो मांगा था, तो sin इनवर्स के फॉर्म में आपको आंसर छोड़ना है. Now come to the fourth one. A point object is placed at the center of glass sphere of radius 6 centimeter and refractive index 1.5. The distance of the virtual image from the surface of the sphere will be. Print आपको ये डायरेक्ट फॉर्मूलेस क्वेश्चन में ही गिवन थे, तो ऐसा न्यूमेरिकल की फॉर्म में भी आ सकता है. प्रिंट यहाँ पे ऑब्जेक्ट इज एट द सेंटर ऑफ द स्फीयर, इमेज मस्ट बी एट द सेंटर, so distance of the virtual image will be 6 centimeter only. Student, आपके पास ये तीनों फॉर्मूले जो क्वेश्चन में मेंशन थे, you must remember those formulas too. Next, in refraction, light waves are bent on passing from one medium to second medium because in the second medium the frequency is different, coefficient of elasticity is different, speed is different, and amplitude is different. The correct answer is speed of the light different because refractive index change होने से speed change हो जाती है, keeping the frequency same. Now come to the next case study, compound microscope. When compound microscope construction and working is also important for your syllabus. Compound microscope. A compound microscope is an optical instrument used for observing highly magnified image of tiny objects. Magnifying power of compound microscope is defined as the ratio of angle subtended at the eye by the final image or to the angle subtended at the eye by the object when both final image and the object are situated at least distance of distinct vision from the eye. It can be given that overall magnification is ME into ME, where ME is a magnification produced by eye lens and MO is a magnification produced by object lens. Consider a compound microscope that consists of objective lens of focal length 2 cm and eyepiece of focal length 6.25 cm, separated by distance 15 cm. Now, first question, the object distance for eyepiece so that the final image is formed at least distance of distinct vision will be. Now student, least distance of distinct vision पे आपको image बनानी है, that is d is minus 25 centimeter here. Apply lens equation 1 by f equals to 1 by d minus 1 by u. So 1 by u equals to 1 by d minus 1 by f. Apply d as minus 25 centimeter and focal length 6.25 centimeter, which is mentioned here. So we can calculate UE from here, coming out to be 5 centimeter. Now come to second question. How far from the objective should an object be placed in order to obtain the condition described in part 1? Now student, आपके पास part 2 में आपको U निकालना है. Again apply lens equation 1 by f equals to 1 by v minus 1 by u. Here in this case, VO is 15 minus 5. It is given in that question. Okay, how far from an objective should an object be placed in order to obtain the condition described in part 1? So आपके पास 1 by f equals to 1 by d minus 1 by u फिर से apply करिए using v as 10 centimeter here, FO is 2 centimeter here. You can calculate E naught, which is 2.5 centimeter. Now come to third one. What is the magnifying power of a microscope in the case of least distance of distribution? Magnifying power of compound microscope. Student, हमें पता है कंपाउंड माइक्रोस्कोप के मैग्निफिकेशन का फॉर्मूला होता है MO into ME या फिर V naught by U naught 1 plus V by F. Apply all the given terms, you will get magnification. That is 20. Now come to next one. 4. The intermediate image formed by the objective of compound microscope is. फिर कंपाउंड माइक्रोस्कोप की अगर आपको रे डायग्राम याद हो तो फर्स्ट हम ऑब्जेक्ट रखते हैं बिटवीन एफ एंड सी फॉर ऑब्जेक्टिव लेंस. वो इमेज बनाता है बियॉन्ड सी, रियल बनाता है, इन्वर्टेड बनाता है, मैग्नीफाइड बनाता है. नाउ द इंटरमीडिएट इमेज फॉर्म by objective is real, inverted and magnified. Now come to fifth one. The magnifying power of a compound microscope increases with focal length of the objective is increased and that of eye lens is decreased. Focal length of the eye lens is increased and the objective is decreased. Focal length of both eye and object lens should increase. Focal length of both object and islands should decrease. Student, magnification inversely depend करता है focal length पे. Student, if focal length is less, magnification will increase. Now come to next case study number 8. Lens maker formula. The lens maker formula relates the focal length of the lens to the refractive index of the lens material and the radii of the curvature of the two surfaces. This formula is called so because it is used by the manufacturer to design lenses of required focal length from a glass of a given refractive index. If the object is placed at infinity, the image will be formed at the focus for both double convex and double concave lenses using the lens maker equation 1 by f equals to mu 2 minus mu1 by u1 1 by f r1 minus 1 by r2. So you can also take mu2 by mu1 minus 1. When lenses are placed in air, mu air is 1 and mu2 is mu. The lens maker will become 1 by f equals to mu minus 1 1 by r1 minus 1 by r2. Now come to the first one. The radii of the curvature of each face of a biconcave lens, biconcave, मतलब R, अगर concave lens आपको याद हो तो उसके दो रेडियस बनते हैं, एक लेफ्ट हैंड साइड पे एक राइट हैंड साइड पे. तो लेफ्ट the first radius will be taken negative and the second will be taken as positive. The radii of the curvature of the two faces of biconcave lens, the focal length of the lens. Now student, apply lens maker equation 1 by f equals to mu minus 1 1 by r1 minus 1 by r2. Use given data, that is 1.5 minus 1 1 by 30 minus of minus 1 by 30. You will get focal length as minus 30 centimeters. Now come to the second one. The radii of the curvature of the lens face or the face of the double convex lens are 10 centimeter and 15 centimeter. The focal length is 12 centimeter. Then the refractive index of glass is. Now student, again apply lens maker equation 1 by f equals to mu minus 1 1 by r1 minus 1 by r2. Apply all the given data, you will get refractive index. Now come to the third one. An underwater swimmer cannot see very clearly even in absolute clear water because absorption of light in water, scattering of light in water, reduction of speed of light in water, change in the focal length of the eyelids. Now student, the eyelens is surrounded by different medium than air. This will change the focal length of the eyelids. The eye cannot accommodate all images so as it's doing air. Student, हमें पता होना चाहिए ciliary muscles जो हमारी आईज के अंदर है वो हमारी आईज की फोकल लेंथ को कंट्रोल करती है और हमारी आईज एक लिमिट से ज़्यादा हमारी जो आई लेंस है एक लिमिट से ज़्यादा कॉन्ट्रैक्ट या रिलैक्स या स्ट्रेच नहीं हो सकता. तो आप जो पावर ऑफ एकोमोडेशन वाटर के अंदर एक लिमिट से ज़्यादा अचीव नहीं कर सकते, इससे आपको ऑब्जेक्ट क्लियरली दिखाई नहीं देते. फोर्थ, a thin lens of glass 1.5 a focal length 10 centimeter is immersed in water 4 by 3. The new focal length is. Now student, apply 1 by f equals to mu minus 1 1 by r1 minus 1 by r. Apply given data. अगर वो वाटर में है तो 1.5 डिवाइड बाय 1.33 minus 1 1 by r1 minus 1 by r2. Now divide the two given equations and hence you will get refracted or focal length of water. Comes out to be 40 centimeters. Now come to the next one. An object is immersed in a fluid in order that the object becomes invisible. It should be behaves as a perfect reflector, absorbs all light falling on it, have refractive index 1, have refractive index exactly matching with that of surrounding hue. So अगर आपको किसी लेंस को डिसअपियर करना है तो उसका रिफ्लेक्टिव इंडेक्स वही होना चाहिए जो रिफ्लेक्टिव इंडेक्स मीडियम का है और रिफ्रैक्शन will not take place. Then the ray will go straight, so it will get disappear. Now come to the next case study number 9. Diffraction through prism. A prism is a portion of a transparent medium bounded by two plane faces inclined to each other at a suitable angle. A ray of light suffers through refraction on passing through a prism and hence deviates to a certain angle from its original path. The angle of deviation is delta, which is mu minus 1 into e, to which a ray deviates on passing through a thin prism of small refractive index a. If mu is the refractive index of the material of a prism, then prism formula is mu sin a plus delta minimum by 2 over sin a by 2. वाइवा के टाइम पे ये क्वेश्चन कई बार पूछा जाता था बाय प्रिज्म. आपको प्रिज्म क्वेश्चन डिराइव करने के लिए आ सकते हैं या उसको न्यूमेरिकल भी आ सकते हैं. नाउ कम टू द फर्स्ट वन. फॉर विच कलर एंगल ऑफ डेविएशन इज मिनिमम. तो स्टूडेंट डिस्पर्जन का एक छोटा सा आप डायग्राम बना के देख सकते हैं. वॉयलेट सबसे ज्यादा डेविएट करता है और रेड सबसे कम डेविएट करता है. The minimum deviation is red, maximum forward. Okay. When white light moves through vacuum, all color have the same speed. Different color have different speed. Violet has more speed than red. Red has more speed than blue. फिर अभी हम इसको पीछे भी कर रहे थे रिफ्रैक्टिव इंडेक्स की टर्म्स में. लेकिन यहाँ पे उसने बोला है एयर. तो इन वैक्यूम या इन एयर जो हम नियर इक्वल मान के चलते हैं all color have the same speed because there is no dispersion of light. जब हम इसको प्रिज्म में इंसर्ट करते हैं तब डेविएशन होता है और तब हम स्पीड को देखते हैं. Now come to the third one. The deviation through a prism is maximum when the angle of incidence will be. The deviation is maximum when angle is 90 degrees. Students, आप deviation angle चेक भी करके देख सकते हैं. जब आप म्यू और गिवन म्यू आपके पास sin 90 sin 91 हो जाता है. Now so sin 90 is 1, which is maximum. Now come to the fourth one. What is the deviation produced by the prism of angle 60? Refractive index is 1.644. Deviation produced करना. आपके पास deviation angle is mu minus 1 into a. Mu is given to you 1.644 minus 1 into a prism angle 60. You can calculate delta. Now come to fifth one. A ray of light falling on an angle 50 degree is refracted through a prism and suffers minimum deviation. If the angle of prism is 60 degree, then the angle of minimum deviation. Now student, apply formula. minimum deviation पे a plus delta minimum 2i के equal होता है. So student 2i means 50 plus 50 100. Delta minimum means 100 minus a. A मतलब prism angle which is given to me as 60 degrees. So deviation minimum is 40. Now come to the next 10. Optical fiber. It's an application of TIR. An optical fiber is a thin tube of transparent material that allows light to pass through without being refracted into the air or another external medium. It makes use of total internal reflection. These fibers are replicated in such a way that light reflected at one side of the inner surface strike the other at the angle larger than critical angle. Even if fiber is bent, light can easily be traveled along the length. Now come to first one. Which of the following is based on the phenomenon of total internal reflection? Sparkling of diamond, optical fiber, instrument used by a doctor for endoscopy, all of these. Student, all of these ये सभी यूज करते हैं टोटल इंटरनल रिफ्लेक्शन के फिनोमिना को. Now come to second question. A ray of light will undergo total internal reflection inside an optical fiber if that PIR की दो conditions satisfy होनी चाहिए. It should come from optical denser to optical rarer medium. Second, the angle of incidence must be more than critical angle. अब यहाँ पे उसने कहा है a ray of light undergo total internal reflection inside the optical fiber if goes from rarer medium to denser incident light at an angle less than critical angle, like at the interface normally is inclined to at an angle greater than critical angle. Now student, its answer is more than critical angle. Now come to question number 3. Question number 3 says if in core angle of incidence is equal to critical angle, then the angle of refraction will be. Now स्टूडेंट जब आप प्रिज्म इक्वेशन डिराइव करते हैं तो वहां पे और मिनिमम डेविएशन रिफ्रैक्टेड रे पैरेलल हो जाती है, तो आपके पास जैसे इंसिडेंस एंगल इंसिडेंस ऑफ एंगल आई इक्वल टू क्रिटिकल एंगल, तो आपके पास पी आई आर के अंदर एंगल ऑफ इंसिडेंस एंगल ऑफ रिफ्लेक्शन की इक्वल होता है. नाउ स्टूडेंट दूसरा प्रिज्म के अंदर आपके पास जब R1 इक्वल टू R2 हो जाता है, I इक्वल टू E हो जाता है, तो आपके पास R will be 90. Now come to fourth. In an optical fiber shown correct relation for the refractive index of the core and the cladding. Cladding बाहर वाले outer covering को कहते हैं, core अंदर वाले glass को कहते हैं. तो core का refractive index ज़्यादा होना चाहिए as compared to cladding. Because अगर ऐसा नहीं हुआ तो आपके पास PIR फिनोमिना नहीं हो पाएगा. बिकॉज PIR तभी पॉसिबल है जब ऑप्टिकल डेंसर से ऑप्टिकल रेयर की तरफ मीडियम आए. नाउ कम टू फिफ्थ वन. If the value of critical angle is 30 degrees for total internal reflection from a given optical fiber, then the speed of light in that fiber will be. Now students, sin c equals to 1 by refractive index, which is speed of light in medium 1 with respect to speed of light in medium 2. Now students, refractive index आपका sin theta अप्लाई करें यहाँ पे, जो वैल्यू गिवन है that is v1 by v2, v2 is given to us, sin theta is given to us, तो आप इसको वैल्यू पुट कर दीजिए, you will get 1.5 10 to the power 8. तो मैक्सिमम वेलोसिटी हो सकती है when the speed of light is, if the value of critical angle is 30 degree for a internal reflection. Now student, we will be back with you. आप पेपर्स अपनी क्लासरूम के नोट्स और केस स्टडी क्वेश्चन बेटा इन सबको बार बार देखते रहें टू गेट अ गुड स्कोर इन योर टर्म टू एग्जाम. ओके फ्रेंड्स, see you very soon. Meanwhile, keep learning.